Hey, hi everyone. In this video, we will explore how to connect our AI SDK agent to an MCP server using HTTP protocol. So in the last video, we built an OpenAI SDK agent and then connected to the MCP server using STDIO protocol, standard input output protocol. In this video, we will focus only on the HTTP protocol of communication between the agent and the server. Okay, so let's see. So in this case example, we will be using the UniProt MCP server. We will download that and run it locally so that the MCP server will be available in this location. Okay, so let's say this is the HTTP URL of the MCP server it is running. So now our OpenAI SDK framework will connect to this server through sending a request, post request, and getting a response. So now, as I said in the previous video as well, the OpenAI framework provides two libraries or two modules to connect to this MCP server. One is the STDIO protocol. For that, we have to use MCP server STDIO, and for HTTP streamable protocol, we'll have to use MCP server streamable HTTP. So since in this video we will be using HTTP protocol based communication, so we'll have to import this library to communicate. So we'll be using the UniProt example, right? So let's say so if you go to this MCP site and if you go to the community one, right? So if you scroll down at the last, you will get a link which will open over here, and you can find many community driven MCP server, and one of such example is the UniProt MCP server. Okay, so this is developed by some people, and this hosts few important tools like UniProt search, UniProt stream, UniProt entry, ID mapping, those kind of tools are available. So basically what we are more interested in, like how to quick start, just check that. So it says that you have to download this repository, npm install will install, and then you have to launch that UniProt MCP server by npm run dev. So this package is written in Node, so that's what we'll have to use npm to launch it. So when we do this npm run dev command, it will host our MCP server in this location, localhost 8787 port, and MCP is the API endpoint. So now we simply have to connect to that using this command. Okay, so this is the JSON block that we need, that means the command to connect. So npx is the command, and we are connecting MCP remote, and this is the URL we have to give. So same as what we use in the cloud, I'll be doing that. And if you go to my repository in this folder MCP with OpenAI SDK, you can look for this HTTP notebook. So that's what we will be seeing. So what the instruction, like we'll be installing that UniProt server. We'll download it. So you can do a git clone, then go to the server and then install and then run it, right? So in my local system, I have downloaded this UniProt MCP server locally, and then I have already installed it, npm install. So it is installed. So just what I have to do, I have to run or launch this UniProt MCP server by this command npm run dev. So when I do this, what it will do, it will now launch an MCP server, and by default it runs on I think 8787 port. Okay, so this is the main URL. You just copy paste, and if you just try on some URL, you will see some messages that this MCP server. So this says that my server is now running. Okay, so let me open to my notebook here. So just a little bit setup, so you can go to the second one here. So okay, so first what we'll need, we need all the libraries, right? So we need this load.env to load our environmental variable. The same thing, repeatable. Repeat, I'm saying, we need this libraries from agents, but most important, we are using this only changes this MCP server streamable HTTP. So in the STDIO, we had used this server STDIO input, but now we are using this one. So let's and also I'll be using my local Olama model. I will not be using the paid model from OpenAI. For that I need to use this to import libraries. Okay, so let me load this module, and now I'm loading my environmental variable. So basically this will load my OpenAI key into my current setup. Now let's before building an agent, what we can do, like we can just see what are the tools this server is provide. So basically the command would be, let me clear all the output. So again, the same for syntax, async with. So this is the syntax for the MCP server. So the MCP server, the protocol is the class, and you can see we need to provide the parameter with the command, how to connect to the server, and the same argument, like you can use cache to list what is the timeout session and what is the maximum retry attempts, retry backup, something we can use. But since so here in this example the parameter is like uh, here we are giving in a JSON schema, right? It needs in a JSON schema. So here the URL is, this is the host URL, and timeout is 60 seconds, and SSE timeout is 300. This is the way we can give over here. This is slightly different than what we saw over here. Okay, uh, we can give in this way. So this is little different than a way of specifying, but you can specify directly the URL here. So this is very straightforward, instead of npx, those kind of things. So you can directly, because this server is running, right? This server, since it is running, okay, already it is running, so we don't have to download and install it. Okay, so that's what the syntax of this one with the previous one will be very different. So in the previous case, when STDIO mode, basically what we were doing, we were giving the command like this, right? So that means we were explicitly uh, you know downloading that, and to download that we had to use this ubx command like that. But now, since the MCP server is running already, we don't have, we are independent from the server is running somewhere. We don't care how it was downloaded and installed, but we have to just communicate. So that's why the syntax will be very different. So here we have to just specify what is the URL of that MCP server, and then you can specify what is the timeout, and SSE timeout is some other parameter you can specify. So this is what the parameters we need to connect to that and already running MCP server on HTTP. So little different from the syntax, you see. That's what I clarified. And also you can give some additional parameter like how many attempts you want, and retry backup seconds, client session timeout. And here you can see I have used an cache tool list equal to means I have told just to whatever the tools you get, you just cache it. So this all will go under this one. So that means I'm calling this MCP server streamer HTTP class object, and I'm storing that as server. So now the server object will now contain this my MCP server, you can see, and within that, inside that block, async block, I am calling server.list2. Again, I will have to use await, because any function call you use in asynchronous mode, you have to prefix this await. So this will now run. What happens? Let's see. Streamable HTTP could not reach to the server. Okay. Oh, okay, I got it. What happens, like this is now running in my Windows host. Okay, so that's the problem, because this because I have two. I have in my Windows I have installed WSL, right? So I'm writing this Python code in WSL. See, WSL. That means this is my Linux. I'm showing in the Python code, but this server is running on Windows host, because this is the PowerShell. So either I have to allow the communication between WSL to this one, or what I have to do, I have to just cancel this. I don't download this Windows. So because since I'm working on Linux there, right? So I'll have to start the server there. Okay. So for that, what I'll do, I'll go over here, the same path. Okay. Okay. So this is my UniProt folder. Here I can see the this UniProt MCP server. Okay, so here I am now do npm, was the command I typed, npm run dev, right? So npm run dev, same command, but now I am in the WSL. Okay, so that's the problem, like, because if you are, because I love Linux, so that's what I have configured my Visual Studio and my system and the Ubuntu, and I mostly use that one. But sometimes when you're doing it will create a problem. Okay, I think. Okay, so what happened, like this, see, while giving the previous video demo, I installed npm install there, so that got So this folder now contains the Windows installs. And so let's firstly I will do that npm install. Okay, sorry for that. Let me pause my video so that it will install. Okay, so what I did, like, I reinstalled it. Just forget, that, I had installed because I had installed on Windows, so I had to reinstall it. So just think from space, like, you cloned the repository and you did npm install. So it installed it. Then I just did the run the same command npm run dev. This is how the instruction of UniProt MCP server says that, you install that and then you run via npm run dev. So now you see this is now running in my this WSL. So let's now connect. Probably it should work, I hope. So now, yeah, so it's now connected. You see, I query, it returned me so many tools over here, right? And you can see that, you also get the server connection, the logs over here. Okay. So far what we did, again, just quick recap. We just, this is, I have not created an agent yet, just, a small snippet that tells like what are the tools available on my server. Okay, so now build an actual agent. Okay, so here first what we'll do, we'll be using my local LLM model. So you can use OpenAI model, but I will be using local one. So my Olama model is hosted in this URL. So I created a client and then I choose what model I want, and using OpenAI chat model, I use the model name and I'm using the client. So using this 3 line of simple code, my agent will now connect to my local LLM model. So here I am given some instruction. You are expert in UniProt. This is the system prompt, and I'm using some session memory so that all my interaction with the agent will be stored permanently. Stored, so chat kind of interactive. It will retain the past conversation of the users. Okay, so here I have defined the chat function, very simple, and all the code what we did previously, right, the same I'm putting it here. So async block, okay, as it is, and within that block I'm creating an UniProt agent. So this is, carefully look. So here I'm defining the agent, giving some name, giving the instruction that hey, you are the UniProt expert. Okay, so the model is the model, this model, that LLM model llama I'm using, and I'm saying that this MCP server is the MCP server. Okay, so now then I have to call this runner.run UniProt agent, and message is nothing but the query. Okay, and return is equal to, it will return this. So this is the chat function I have defined it. Okay. Okay, so now here basically I'm creating an interface. Okay, so this is from Gradio app. Use gr.chat interface, pass the chat function, and you launch it. Okay, so let's try with this first model. If this doesn't work, we'll have to use some powerful reasoning model like GPT OSS alternate model also we can use. Let's see if this model is sufficient to handle this query or not. So for now I'm just commenting this and we'll go in, because this is super fast. GPT OSS will take time. So let's run this. Okay, so it will open now in chat interface through which we will interact. So I will ask, I'm just copying this query. We'll ask the chat agent like get UniProt ID for this gene TP53. Just 5 is enough, only UniProt ID. So let's open the chat interface. So it created this chat interface. So I'm just clicking it. So it will open a chat interface. Very nice. See. So here let's put this question: get UniProt IDs for the gene TP53. Just 5 is enough. So let's see. So I put a question over here. So let's go back to traces and see how it works in the behind the scene. So let me refresh over here. Okay, see, so I'm just clicking over here. Yeah, it will take some time. First it called the list of MCP tools, so which return all the tools from the server. So this is the first thing always an agent does. Like agent first calls, hey server, what are the tools you have available? So now from this, what it get, like for every tools and it's all schema it will get. Okay, so now based on the knowledge what it gained, it will try to call. So I'll pause my video, let it finish, then I will explain how the tracing it work. Okay, yeah, I got some error actually. So what it did, it called the tools, then it tried to call the same query. It called the UniProt search, the first one, but somehow it gave an error, that error invoking MCP tool UniProt search on server. Okay, some issue happened, probably it's saying that it's not the way I should call. Okay, so invalid argument for tool UniProt search. Okay, so that's where probably I will just try with a different model. Okay, because this model is not able to, it's a very small model, maybe it's not good. Okay, so let's comment this one and open with the GPT OS. This is very powerful model, so it is very good in tool calling. So let's try again. Okay, I will call the same question to this one. Okay, let's copy this one and paste it over here. Okay, so now this is a reasoning model. GPT-OS is a reasoning model. It will also give us the reasoning, like how it works. But again, this is a very slow one. I'll have to pause. But meanwhile, I will show you the traces back here. It first called again the tool search. So this is the the protocol is streamable HTTP, and this is the place where it is running. Okay, again it will be very slow because it's running on my system. So I will pause for a few seconds and I'll be back. Hey, we got an answer, like the IDs. So let's see how the traces work. So it was not expecting the way. I will show you what happened. Okay, so you see when I call, right, first it calls these tools. Okay, then it calls like, hey, this is the system, this is the user asked this question. So it correctly called UniProt search tool. Okay, but somehow it was not able to call it properly. But the reasoning, you see that this is a reasoning model, GPT OS, right? So what it does, like the user wants 5 UniProt ID for the gene, this one, so need to fetch UniProt ID for the human, this one. So likely something, and the explicit ask is just 5 is enough, so only UniProt IDs. So the reason is now thinking, and then based on that it called this tool UniProt search, and it gave some error, some field validation issue, and based on that it now retried. Okay, so again it called the tools, got the schema, and then it called the it's thinking that the error says that primary accession is invalid field, we need to return UniProt ID so we can use the field accession, so modify the query. So now it again called the second time, tried something, and again it got an output, some bad request, probably did not work. Okay, so then again it tried to probably improved schema, and third time it called the again using a different way of calling, and then it got some answer as an output. So that's what these reasoning model, they can think, they can plan, and then connect, and they improve based on they observe their output, and based on that they improve, they correct in themselves, and finally we got an output from that. Okay, so that's what you saw the output, like this. But in short, the idea of this is like using this command, right? So basically same command, but here we have different given differently. So sorry, I can show you, right, what is happening behind the scenes. See, so many post requests it's sent, right? This is the server where it is running. So wherever it was getting, right, the question, it was sending the post request, and the response was through the get, like that. So yeah, so this is in summary, to use an OpenAI SDK agent through HTTP protocol. Let's say already you run a server anywhere. Let's say it is running somewhere. You can call async with MCP server HTTP, and you pass this URL, and that's all. And you can create a server object and define your agent, pass this MCP server with the server, and then ask the question to the user to navigate. So in short, we need a good powerful LLM model to work with MCP server. Initially, we tried with this Llama 3.0. This is very old model, so it could not handle this thing. But then I modified with GPT OSS model. Then it was the reasoning model. It failed. Then it improved himself and tried 3-4 times. Then it worked, right? But alternately, you can use because this was a very local model. Okay, but alternately you can use the powerful GPT 4.1 or 5.1 model. Actually, the OpenAI model. This will give you faster response and correct. Okay, that's all. In short, what we saw in this video is like, we connected a MCP servers via HTTP protocol, and we used OpenAI SDK agent. So you can also use other SDK agent the same way. All the philosophy is very same. Syntax might be very different. Okay. So okay, that's conclude our phase one. So we in this phase one, last couple of videos, what we saw like how to use an MCP server. So basically, MCP server was developed by someone else. We connected our agent to it. So then we learned two approach. First we saw cloud desktop, the AI assistant to connect to the MCP server, and also we talked using an OpenAI SDK agent, more programmatically how can you interact with the MCP server. So both are good and bad. So the good is like a cloud desktop is very easy, just UI interface, you connect it, very simple, and you can cloud desktop can do everything for you. But the only disadvantage is like you cannot build your own custom agentic AI system. You need a lot of flexibility is not there. But the comparatively, using an SDK agent provides full flexibility. Only thing is like it's a very programmatical way and of doing it. So, but yeah, so both has pros and cons, and both learning is good. That's what I put this all I try to talk included this both into the video series. So that concludes the use one. So in the next video or in the next phase, we'll move to the phase two, where we will build our own custom MCP server. Okay. So I hope you, this was useful, and if yes, please support the channel. So I will see you in the next video. Thank you.